Hello everyone, we continue doing LOL maths with the circles, and the next step is to consider intersections of lines with circles. So what I mean by saying intersection of lines with circles, so the line is a straight line and that's one object here and the circle is another one. So we're looking for common points where lines meet a circle. That's the standard question in A-Level Period 1 and this new syllabus for 2020, 21 and 22. Alright, so we're going to recap a little bit about straight lines. However, this topic you might find in GCC section and also in A-Level section for just recap. We are going to recap straight lines quick. And right now, I just want to tell you what means the straight lines with the parameters. Alright, so generally you can set up the line as the following: y equals mx plus c. This is just linear dependency between x and y, and m and c are coefficients in this case. Okay, so we can say that m and c are sort of parameters. They're numbers in a given case. For example, for a given straight line, you will have definite values like you can see here. For this line that you can see on Cartesian plane, here is m equals to 1, that's the gradient, and c, which is y-intercept, is going to be -2. But in general case, there are sort of parameters, and we can play with their parameters values in order to set up a set of like family of lines, family of straight lines. Okay, why we need that? We need that for the following consideration. So let's assume we have a circle with a certain equation: x minus 3 squared plus y plus 1 squared equals 8. So we have the circle with the radius square root of 8 and with the center, according to the coordinates and general standard equation of the circle, x is going to be 3 and y is going to be -1. That's the center. You just may have a look at those numbers. Okay, so here you can see the title for the slide: possible values for y-intercept as a parameter. So we're talking about general equation of the line y equals mx plus c, and we're going to consider parameters for y-intercept. So we need to have a specific value for m for the gradient, and we are going to play with the c value in order to probably meet conditions in given problem. Okay, so for example, let's consider a given equation: y equals 0.5x and plus c. So I set up the value for the gradient, which is in this case 0.5, and what I'm going to say that we can play with the c value as the y-intercept in order to see where this line, with this particular line, will meet the circle, at which points. So general consideration, if we have 0.5x, and let's consider first basic straight line, which goes with the gradient 0.5x and y-intercept at the origin. So we can set up this line as the following. So let's set up this point. So gradient 0.5. So when x is 2, y is 1. So the line will go through these points, through the origin and a given point 2 and 1. Okay, so this is the basic line, y equal 0.5x. And what I'm going to do right now, I'm going to play with the parameter of c. So I can live by c units up from the basic line, from the origin, and I also can put this line down. Okay, so what I'm going to reach, you understand that in this case, because the gradient is given for you is 0.5, the gradient is fixed, and you can play with the c value. You can make up or down translation, basically vertical translations. Okay, and what I'm going to reach, I'm just trying to, I want to explore for which value for c I will have, for example, just only one touching point. All right, as you can see here, that's one case. All right, so that's one case. What I'm going to do right now, I'm just going to fix this line over here, and I'm going to make clone with the same gradient, and I want to see where this line also has intersection with the circle and only one touching point. So obviously it's gonna be somewhere here. All right. So at least we can estimate that from this value around 1. So I may say this is around 1. And from this value for C, which is around -6, maybe -5.8, so we will have the range for all possible values for C where we have intersection with the circle. So that's the critical case, and this is upper bound where we have only one touching point, and this is the lower bound where we have also one touching point. Somewhere in between, for this range, in between, we can set up this range, let's say using this color, from here to here. That's all possible values for C, okay, for the parameter C. That's the range for C, for C, where we have intersection. We can guarantee that the line will have intersection with the circle. So I'm going to say that somewhere, that's my estimation, graphical estimation, from let's say -5.8 up to somewhere 1, we will have one touching point or 2 points of intersection. And indeed, if we just go back here and just copy this line, come on please, copy. Okay, so somewhere in between we will have definitely 2 touching points, as you can see. All right, so I just want to kill that quick, and that's how we can explore and find out for which y-intercept or for which value C as a parameter we will have given numbers of intersections with a given circle. All right, so later on I'll show you how to do it algebraically, and now we're just going to for the next exploration we are looking for the gradient as the parameter in this case. All right, so what we're gonna do, we're gonna explore the gradient as a parameter. So in other words, we can say that we have y equals mx plus, and c should be given for you, for example 2. Okay, so let's say we have c fixed, in this case it's 2, and now we're gonna play with m as a parameter. Okay, so let's set up our straight line that goes through 2, and so this is 2, that's going to be C and y-intercept, and we are going to explore for which value for m we might have intersection with given circle. So equation of the circle is still the same, is centered here with the radius square root of 8, and right now what I'm going to do, I'm just going to explore. Okay, so I'm going to use yellow color. All right, so this is going to be the first gradient, and that's going to be one value, starting from which one we can guarantee if the value is lower than this critical value m1, we will have possible points of intersection up to where? Up to this gradient, because this, in this case, that's going to be another value m2, so that in between we can guarantee that the line with the equation y equals mx plus 2 will have at least 1 point of intersection, so at least 1 point. So for this given value m1, it should have only single point, as well as for this critical value. Somewhere in between we can guarantee that. So So we can guarantee that if m in between, so m2 and m1, we will have points of intersection with the circle. However, somewhere outside, for example, if you take this line that goes through 2 and just you increase the gradients and make it positive, so there will be no points unless, again, we will reach this critical value where we have a touching point, because line goes also down, and that's going to be another value for m, which is going to be m2, so that the line will touch the circle at one given point. All right, so I hope you understand how to explore. There might be another case I just can mention briefly. So for example, we can have parameter in the equation of the circle. So for example, let's set up x minus some value r is not going to be the radius. Maybe let's put p squared, and let's put another one, x plus some given value for y as a center equals to, let's say, 9. So for example, for this equation and for a given line, let's say 3x minus 1, we can again set up the reasonable question for which value of p as a parameter. So we need to find p value. Obviously, it's going to be the range for which we have, let's say, one single point with the given line. Okay. Again, we need to arrange a system if we want to approach algebraically, or we just can put this circle and play with the parameter p. It's going to be the basically x0 coordinate of the center, so that we can move it definitely horizontally, because in this case circle can be moved horizontally, and we're looking for all possible values for intersection with the straight lines 3x minus 1. So I hope you understand how to play that with that, so you can just model that. You can take this topic for modeling if you like, if you want to do some internal project like internal assessment. Okay, that's also be useful for GC students who are going to explore the circles on more advanced like level. Okay, this is going to be a good project for you guys. And finally, what I'm going to consider how to solve algebraically so that possible values for y-intercept as a parameter, if we want to find, say, for which values of c for the given line 0.5x plus c, this line will have at least one point of intersection with the circle. All right, so one more time, the question is to define c value. That's going to be the range for c where the line 0.5x plus c will have at least one point of intersection with the circle with the given equation x minus 3 squared plus y plus 1 squared equals 8. The circle you can see graphically here. Alright, so try to do by your own, grab pens, grab notes, and try to accomplish this task, and let's consider my explanations. Alright, so what I'm going to do, I'm going to approach this problem algebraically. For this reason, I need to solve simultaneous equation with x minus 3 squared with the equation of the circle, basically. So that's going to be equal to 8. And what I'm going to do right now, I'm going to express y through x. It's already expressed in equation 1 of the straight line. And I want to plug into the second equation. Instead of y, I'll plug the right side. So basically, I'm trying to solve the system of equation. And what I'm going to do right now, I also want to expand those brackets. And that's going to be x squared minus 6x plus 9. Here, I'll just plug 0.5x instead of y plus c. And also, I want to add 1, right? So what I see here, I just want to write opifine x plus c plus 1, okay? Plus c and plus 1, which is going to be squared in this case, equals to 8. Alright, so let's do that. X squared minus 6x plus 9. Here, I square this up and I'll get 025x. Then, so I consider c plus 1 as just one part of binomial, basically another number. And I multiply by 2, so there's going to be x times c plus 1. And then I'll square up c plus 1 squared, which is going to be c squared plus 2c plus 1. And I also transfer a to the left side. Alright, so that's more about how well you can simplify this polynomial as quadratics. So I hope you understand how to work with quadratics. Now, next, I'm going to do that. Oh, my bad. So 25x squared, of course. And here I will have 125x squared. Then I will have minus 6x. So 9 minus 8 is going to be 1, plus 1 is going to be 2. So I'll get plus 2. Next, I'll stay with this part. So it's going to be x c plus 1 plus c squared plus 2c equals to 0. So, and finally, what I'm going to do, I'm just going to simplify and write 125x squared. Here, I'm going to have, so 2 on transfer here. So that's going to be free coefficient, and minus 6x plus x is going to be minus 5x. So it's going to be plus x and c minus 5. So I just factorize x. And finally, I'll get this, c squared plus 2c and plus 2 equals to 0. Alright, so just make sure you understand that this x squared plus bx and c, which is another c, let's say c star x, c star, it's going to be not c that I have an equation. So that's generally quadratic equation. All right. So I tried to transfer this stuff. Just copy and probably in this way. So I'm trying to transfer it here. Okay. Yeah, perfect. Okay, so I transfer this equation right there, and what I'm gonna do, I'm just going to solve that using discriminant. So as you remember, it's quadratic formula, and I can use that. But I'm not going to use x values because I want to answer the question. So find the C range so that we will have at least one point of intersection. All right. So that's why at least one point. So that means discriminant. If I'm looking for discriminant, I'm looking for x values. So that's going to be more or equal than 0 for at least one solution, right? So when discriminant is 0, that's going to be one solution. And when discriminant is more than 0, we will have two solutions. It means two possible points of intersection, for example, like this, okay? So that's definitely 2 points of intersection. And right now, we just looking for discriminant. So discriminant is b squared minus 4ac, and c is not this as we have in the equation, so it's different. Okay, and right now I want to construct discriminant as c minus 5 squared minus 4 times 125, yeah, it's gonna be here, minus 4ac, so there's gonna be basically 5 times, and what I have here is that one, c squared plus 2c and plus 2. Alright, so if I simplify that, I'll get the following: c minus 4c minus 4c squared minus 4c squared minus 20c and plus 35. So I hope it's correct. And finally, yes, and finally, what I'm gonna do, so it's gonna be, let me see, 25, maybe not. Let's play with numbers. So minus 40c squared minus 10, and here is going to be minus 10, yeah, minus 20c. And the last one is going to be 25 and minus 10. Yes, it's minus 10 here in the end. I'm pretty sure, yeah, it's going to be, yeah, it's going to be minus 10, so there's going to be plus 15 here, okay? So that's discriminant, and in general case it's more equal than 0. So right now we have inequality and we need to solve that. So just one first, the way I used to solve that. So I just simply used, let's set up this is just Cartesian plane. I understand that this is parabola, so left hand side is the y value, it's parabola, and because it's quadratic in terms of c, so y from c, I consider that one, and I'm just making the sketch, so the sketch is this one, okay? So I'm looking for those c values, c1 and c2, and I'm looking for where parabola, where y value is more equal than 0, so here's the range. So my final answer is going to be c in between. I want to include boundaries because we have non-strict inequality from C1 to C2, and right now I'm going to use the same discriminant in order just using calculator. So right now I'm just actually tired up by calculating manually. Okay, I'm going to use C value when I just simply equate that to 0. So 4c squared minus 20c and plus 15. This is going to be quadratic equation I'm going to solve with respect to c, and I'm looking for c value. Okay, so let's calculate. If I use minus, I'll get c value is going to be negative 0.66, and when I use plus over there, I'll get 5.66. Okay, so my final solution, I found the values, and I can say that for c values from negative 0.66 to 5.66, we will have at least 1 point of intersection. So somewhere in between, that's going to be 2 points definitely. And that's how you can solve it graphically. But just hold on and let's come back. Remember, we estimate the c value from negative 5.8 to 1. We were pretty close. Let's just compare with what we have. It's going to be negative 0.66. That's what we found. Actually, maybe I think we need to swap the signs. Yeah, because it was incorrect a little bit. So what I'm going to do, I'm just going to correct the signs because that's going to be positive and that's going to be negative. So now that's correct. And I just make some adjustment to the final answer because I did it like by using estimations. So, okay, C from negative 5.66 up to 0.66. That will give correct answer for at least 2 points of intersection. Alright, so that's going to be somehow like this. And for another, C-intercept is negative 566 with the same gradient. It's going to be something like this. Alright, and just move a bit down. Okay, so but graphical solution also works if you're required to estimate it graphically. Don't forget that you can just simply play with the C value as a parameter, basically translation, vertical translation, and you can quickly estimate your results for desired, like, so that it meets conditions. Alright, so hope you like that, hope it's clear for you guys. Don't forget to subscribe if you're new here. Don't forget to check out my dance channel. You can find me on YouTube by searching the keywords Daniel Dallas Dance, and you'll see lots of video clips dedicated to dance. There are lots of animation style. There are also breaking if you like breakdance, so you're welcome. If you want to start the learner, so please join and learn with me together. And don't forget to share your comments about prospective topics. So one more time, my primary goal is to clarify GCSE, some gaps, refill the gaps, and also continue A-level maths. Thank you and see you next time.